Welcome to my YouTube channel. This is A Square Maths Made Easy Academy. Now I'm continuing with the next question on what? Calculations in calculus. We stopped at question number 12 in my previous video. Now I want you to note something here. If you have not subscribed to my YouTube channel, please do well to do that, and also like, comment and share. Now remember that this calculation in calculus, I'm treating first 100-word question. We stopped at question number 12. Question what? Number 12. And the method that I'm using is in two ways. The first one is the normal method for those that are writing what? Theory question. While the second one is shortcut method for those that are writing what? Objective word question. Are you with me? Now I want you to cue in and relax your mind as you flow with me. Now question number what? 13. Let's go. Now this question says, I want you to watch. Today edition is part 4. Is what? Part 4. Now let's solve this question number 13. Evaluate limit as x approaches what? Minus. As x approaches 0 what? Minus. I have with me x all over. This is called absolute value. This is called what? Absolute value of what? X. Then plus what? 7. And these are the options. Now I want you to watch now. Let us solve question number 13. Now the question says the limit of what? X approaches to 0 what? Minus of what? X over absolute value of x, now plus what? 7. Now somebody may ask this, what type of limit is this particular question called? We call it sided limit. Sided what? Limit. And sided limit comprises or is divided into two. And the first one is left hand sided what? Limit. Are you with me? Left hand sided what? Limit. And the law is that when x approaches what? 0 minus. So it implies that anywhere we see absolute value of x, remove it and introduce minus x. Are you with me now? Remove the absolute value and attach minus to the x. That is the principle. This is number 1 type. Now the second one is what we call right hand sided what? Limit. And the rule of right-handed sided limit says when x is greater than 0 what? Plus. So when x approaches what? 0 plus, it implies that anywhere we encounter an absolute value, remove it and introduce what? X. That is the difference between x approaches 0 minus and x approaches what? 0 plus. Now this one is talking about 0 what? Minus. So which means it's tending to infinity, right? I am going to now consider this as limit of what? X. I want you to be careful here. Then all over, I have seen an absolute value and it is 0 minus, right? And the law say remove the absolute value and introduce minus to the x. So I will now call it minus x. Are you with me? Then plus what? 7. And that is all. And as I'm doing that, don't forget that this time around, it is no longer sided limit anymore. It will now be ordinary what? Limit. And the law says as x approaches to what? 0. Have I made myself clear? Now if I continue, I'll be having limit of, now somebody talk to me, x over minus x will give us minus 1, then plus what? 7. Then as x approaches what? 0. Can we continue? This is now limit of minus 1 plus 7 will give us what? 6. As x approaches what? 0. There is a condition. Anytime you have a constant limit, the law say as far as x approaches to what? 0. Are you with me now? The result of the limit is the constant. And what is the constant? 6. Have I made myself clear? That is the final word answer. But if I have x here, it means that anywhere I come across x, I will introduce 0. But there is no x. So which means the final answer when the limit moves to the left hand is what? 6. Do we have 6 in the option? Let's check. Option A says what? 7. No. Option B says what? 6. Wow. The correct answer in the option is option what? B. Are you with me? Now can we move to question number 14? Question number what? 14. Let us exactly look at question number 14 and know what we are talking about. Question number 14. Now watch. The question says, given that y is a cos kx plus b sine what? Kx. Now the question says evaluate the square y over the x square plus k square y is dash. So look at the options. We have to evaluate this. Now what is the question? We are given that y is equal to a cos what? Kx. Are you with me? Then plus what? The next one is what? B sine what? K what? X. Now we are trying to observe something here. Watch. This thing that you're seeing here, the square y over the x square, means that we should differentiate this particular equation how many times? 2 times. And that will lead us to what we call second order derivative. Second order differentiation. Are you with me now? But if it is only dy dx like this now, it is talking about first order, which is ones. So I want to differentiate this into, but let me shock you a little. I want you to take note of this, please. Number one is that anytime you are asked to differentiate cos x, cos always go with minus. Are you with me now? Then differentiate that cos, it will give you sine. Then repeat this value, which is what? X. And that is the final what? Answer. So which means the differentiation of cos x is always minus what? Sine x. Are you with me? Now for instance, if you are given cos 3 what? X to differentiate, you should also know, because it is cos goes with what? Minus. The next thing is to differentiate 3x. I have taught you in my previous video. If you differentiate 3x, it will give you 3. Am I communicating now? Then the next thing is that differentiate cos. Cos will give you what? Sine. Then repeat the function. What is the function? 3 what? X. And that is the final what? Answer. Do you understand? Then I will now take you to another note. Anytime you are asked to differentiate this, which is sine x, please, the answer is always cos x. Have I made myself clear? Now let's take, for instance, you are given this. Differentiate what? Sine 3 what? X. Remember that the first thing is to do is to differentiate 3x. It will give you 3. Are you with me now? Then secondly is to differentiate sine. Sine is what? Cos. Then repeat the function. And what is the function? 3 what? X. This is exactly what I want to do here. Have I made myself clear? Then let's continue now. Watch. So let's take it one after the other. Now I want to differentiate. If you differentiate y with respect to x, it will give you dy all over what? Dx. Then equal to. The law said differentiate one after the other. This is a constant. Are you with me? And there is cos, right? I told you, anytime you see cos must always go with what? Negative. Then this is a constant, bring it out down, which is a, because it's attached with the function. Then what do? You first of all differentiate kx. What will kx give you? What will kx give you? It will give you what? K. Then what is cos? Cos is what? Sine. Repeat the function. What is the function? Kx. I am done with this analysis. Then I will move and go to the second one. Are you with me now? Now look at the constant. What is the constant there? B, right? Now I want to observe here. Please, this is what? X, not A. So what do? Differentiate kx. It will give us k. Am I communicating? I have taught you. It's just somebody said differentiate 3x. What is the answer? 3. Then differentiate kx. What is the answer? K. Differentiate bx. What is the answer? B. Can we continue now? The next thing is to differentiate is what? Sine. Sine will give you cos. Are you with me now? Then repeat the function. What is the function? Kx. Now this one is called first order derivative. First order what? Derivative. Can you see? I only succeeded by differentiating once. But it is not the last option. The last option says differentiate twice. Then can we move again to the second one? What do? Anytime we are differentiating the y over the x, it will give you the square y all over the x word square. And this is what we call second order. Now can you observe that this particular x function and this one corresponds, right? Oh yeah, let's continue. This is now equal to. Then what am I supposed to do? Watch now. I will now bring the constant. What is the constant? Minus ak. Minus what? Ak. Now let's differentiate sine k what? X. First thing we are going to do is to differentiate kx. What is the answer? K. I will now say times what? K. Next is to differentiate sine. Sine is what? Cos. Bring the equation back, which is what? K what? X. Close the what? Bracket. I am done with this one. Are you with me now? Then, can you observe that here is cos? And I always tell you, anytime you are differentiating cos, what comes to your mind is negative. Then what is a constant? B what? K. Then I will multiply. Can we now differentiate Kx first? What is Ks? Ks will give you what? K. Are you there? Then what is cos now? I will now put what? Sine. Then repeat the function, which is K what? X. Close the what? Bracket. This is what we call second what? Order. Can we now say the square y all over the x was squared is now equal to, this is minus a, right? K times K will give us K squared, followed by cos what? K what? X. Close the what? Bracket. Then minus, this is B, K times K will give us K squared, followed by sine of what? K what? X. I have known the square y all over what? The x was squared. Then can we now go back to what we are looking for? Oh yeah, we now recall that we are asked to simplify the square y all over the x squared, watch, plus what? K squared, then y. Can we substitute now? Now, do you agree with me that we have already known the answer to this, right? Which is everything here. Can I fix in there? I will now have the square y over the x squared is this. And what is it? Minus a k squared cos k what? X. That is this. Minus also b k squared, then sine what? K what? X. If that is taken, I'll move here. What is here? Plus, right? And I'm left with k what? Square. I have seen what? Y. What is y? Look at y, the question. I will now open the bracket and now identify the value of y. What is the value of y? It is a cos what? Are you with me? Cos k what? X. Close the bracket. Followed by plus b sine what? Bracket k what? X. Close the what? Bracket. What is my target? Is to use this k square to open the bracket. Can we do that now? Now watch. If I should open the bracket, I want us to take it gradually. I will now say this is now equal to, watch this, minus a k square followed by what? Cos what? Of kx, which is this, minus b k square followed by what? Sine of what? K what? X. Are you with me? Then plus, I will now open the bracket. K square times a cos kx will give me now k square. Are you with me? K what square followed by what? Or I will call it k square times a will give me a k square followed by what? Watch. Are you with me? Followed by what? Cos of k what? X. Close the bracket. Then the same k square times b sine kx will give me plus b k square followed by what? Followed by this, which is sine of what? K what? X. I have expanded it. Can we now look at what we are going to get here? Are you ready? Then what do we say? Here is minus a k square cos kx. Oh my goodness, plus what? A k square cos what? Kx. This one will disappear with this one. Am I communicating? Then minus bk square sine of kx plus bk square sine of kx. It will also disappear. So which means the final answer is what? 0. And that is all. Now let's check the option. Do we have 0 here? It cannot be this, no. It cannot be this, no. It cannot be option C. Wow, the correct answer in the option is option what? D. We have simplified it or we have evaluated it. Are you with me? Let's go to question number 15. Question number what? 15. Question number 15. Now, what is question number 15 talking about? Now, watch this. Given an inverse function f such that block 0 comma plus infinity bracket map block 0 comma plus what? Infinity bracket. Now the question says defined by f of what? X, which is equal to square root of what? X. Now what is the question? Find f inverse of what? X. Now I want you to observe here. This thing that you see now, we call it domain, and this one we call it what? Range. This particular function now, I believe that this is the domain and this is what? The range. Yes, it corresponds. Then, but that is not our major concern. Our concern is to find the inverse of that very word function. Are you ready now? Now, what are we given? F of what? X is given as square root of what? X. Are you with me? Now, listen. Anytime you are looking for an inverse function, it is obvious. Always make X subject of the formula. That is all. Then how do we do it? First of all, do you know that there is another way of writing f of what? X. What do we call it? 1, right? And this is now equal to square root of what? X. What is my target is to make X subject of the formula. How do I remove this square root? I will square both sides. I will do what? Square both sides of the equation. Now, if I square both sides of the equation, I will now say y squared is now equal to square root of x, then all what? Square. Now, can you observe that this square root will cancel this square? We have succeeded by making x subject of the formula. So, which means my x now should now be equal to y squared. Am I communicating now? Should now be equal to what? Y squared. Now, there is a rule in a function. Listen. If you are given f of x like this to be equal to y, let's take peradventure now. I want to make f subject of the word formula. I don't need this f now. Do you know that I can say divided by what? F. I can say divided by what? F. So that f will cancel what? F. And this implies that the x we have made the subject of the formula is now the same thing as y all over what? F. Are you with me? And this y over f is same thing as 1 over what? F times what? Y. Now let us obey the law of indices. So what do we say now? That the x now is now equal to f inverse of what? Y. Look at it. By law of indices, f inverse of what? Y. So which means in a function, having made x the subject of the formula, we should recall that the x now is inverted. And how do we write it? F inverse of what? Y. And don't forget that y is always a function of what? X. So what do we do? Let's go back to the business now. Are you with me? Of the day. Now I want you to observe something critically now. This is where we stop. Are you with me now? So what is x now? X is what? F inverse of what? Y. I will now remove it and introduce f inverse of what? Y. Everything now should be what? Y squared. Should be what? Y squared. But mind you that y is a function of what? X. So we are going to substitute for y and introduce what? X. So what will it give us? We now be having f inverse of what? X, which is what we are looking for in the question. Is now equal to what? And y is what? X, but x squared. This is the final what? Answer. So which means if you observe this thing critically, the whole of this means x map. X what? Map what? X squared. Map what? X squared. Either you leave it this way or you leave it this way, and that is the final what? Answer. Can we now observe whether something like this is in the option? Let's go. The first one says option A, x map what? 2x. No. Option B, x map what? X squared. Wow. Look at it. X map what? X squared. So which means the correct answer here is option what? B. Have I made myself clear? Now this is exactly how to solve an inverse function. The rule is that always make what? X subject of the word formula. And you now recall that that x you've made the subject of the formula is now f inverse of what? Y. And this y now has become the domain of what? X. And x is the range. Have I made myself clear? Can we now move to another question? I stopped at question number 15, but I have to continue with another word question, which is question number 16. What did I say? Question number what? 16. Anywhere you are, I just want you to free your mind. Make sure that you watch this video from the beginning to the end. And also share it, please. And comment on it. Now, can we move to question number 16? Question number what? 16. Now, let's look at question number 16. What is it talking about? Are you ready? Question number what? 16. Watch. Question number 16. Now, look at the question. The question says, if x squared plus y squared is equal to 4. Now, the question says, find the y all over what? The x. Can we look at the options? Option A says what? 2x all over 3y. Option B says what? Minus x all over y. Option C says what? X all over y. Then option D says what? Y squared all over x. Are you with me? Now look at this particular question. The question is find dy dx. Now what is the nature of this question? This question is what we call differentiation by implicit word function. What do we mean by implicit function? It is a combination of dependent variable, which is x, which is y, an independent variable, which is what? X. Now, when both of them are being combined together, it is called implicit function. But if it is separated like this form, can you see that this time around, it is separated? It is no longer by implicit, we call it by what? Explicit. But if I have something like this, and the question says, differentiate this, this is what we call implicit word function. It is a combination of dependent variable, which is y, and independent variable, which is what? X. Can we observe this? I want to solve this normal first. After solving it normal, I will now use shortcut, and the answer will do what? Appear. Can we start? This is x squared, right? Plus y squared, and everything is given as what? 4. Now the rule is that if you are differentiating x, don't put dy dx. But if you are differentiating y, put dy dx. Do you know why? Y is a function of what? X. Am I communicating? Y is dependent of what? X. And x is independent what? Variable. Now let's take it one after the other. Can we differentiate this? What is the law? Look at my video part 1, part 2, and part 3, because we are in part 4 now. What is the law? The law says consider the power. What is the power? 2, right? Then after that, repeat the question. What's the question? X raised to the power of 2 and introduce what? Minus. I'm done with this now. Then I will add. I will now move to the second one, which is y. Differentiate y squared. Consider the power. What's the power? 2. Then the next thing is to repeat the question. What's the question? Y raised to power 2. Then introduce minus 1. At the end, we now say equal to. Differentiate a constant. What is the result? 0. Because there is no variable attached to it. Have I made myself clear? And I want to take you back again. It has not finished. Remember, I told you before, when you differentiate y, remember to put dy all over what? Dx. Because y is a function of what? X. Now let's put equal to. The next thing is to differentiate 4, which is a constant. What is the answer? 0. Can you now see? This is 2, right? This is what? X. 2 minus 1 is 1, which is same thing as 2x. Then plus, here is 2, right? Y. Then 2 minus y, which is same thing as 1, and same thing as 2y. And this is dy all over what? Dx. Everything should be equal to what? 0. What do you think that will happen here? Collection of like terms. I will now take 2x to the right hand side, leaving what? 2y dy all over what? Dx. Then equal to. By the time 2x move to the right, it becomes minus 2 what? X. Can you see that my target is to make dy dx subject of the word formula? I will now divide by the coefficient. What is the coefficient? 2y. I will divide this by 2y. I will divide this by 2y. Can you observe here that 2y will cancel what? 2y. So which means dy all over dx is now equal to, be careful, 2 up here will cancel 2 down here. What is remaining? Minus x all over what? Y. And that is the final what? Answer. Do we have something like this in the option? Let's check. What is here? 2x over 3y? No. What is here? Minus x over y. What is here? Minus x over y. The correct answer is what? Option what? B. Do you understand? This is just exactly how to solve it in terms of what? Theory. But I want to use shortcuts. What did I say? Shortcut to solve this particular problem. And what is the question? That we are meant to differentiate this x squared plus y squared then equal to what? 4. Look at the secret, please. The first thing to introduce, this is a constant, throw it away, is to have dy all over what? Dx then equal to. What is the rule? We ought to the numerator always introduce minus. I said to the numerator always introduce minus and differentiate x only. And what is here? X squared, right? If I differentiate x squared, consider the power. What's the power? 2. Repeat the question, which is x raised to power 2, and introduce minus 1. Then I will introduce over. and move to the denominator. In terms of the denominator, only you should do there is to differentiate y. So this is y, right? How do I differentiate it? Consider the power. What's the power? 2, right? I will now repeat the question, which is y squared, and introduce minus 1. Now, can you observe this is now minus 2 what? X. 2 minus 1 is 1 already, over what is here? 2 what? 1. Y. 2 minus 1 is 1 already. What do you observe here? 2 down will cancel 2 up. So finally, dy over dx is always minus x all over what? Y, with this type of what question. Have I made myself clear? Now the rule of the game is that you should observe the numerator, and the numerator must always incur minus. That thing is always constant. And once you observe it, so what you are going to do now is just be differentiating x. Then we move to the denominator. Denominator is just to differentiate what? Y. I will teach you more, especially when we have something like this now, which I know that very many of you will ask such question. What if it is in this way now? How do we differentiate it now using what? Shortcut. And that will lead me to my next video, which is part 5. I will try to introduce this kind of question because this one is splitted already, straightforward. But this one, there is a combination of x and y together. Then how do we use shortcut to solve problems like this? I will take you on part 5. But let's continue with another question, which is question number 17. What did I say? Question number 17. I just want you to pay attention. Number 17. Question number 17. Question number 17. Now let us look at what number 17 is talking what about. Hope you're following exactly what you are doing. Now, oh my goodness, look at this question. The question says, find the derivative. Find the what? Derivative of, look at this, y equal to log of x plus 1 all over log of, I mean to say 1 plus x all over 1 minus x base what? A, where the value of x cannot be equal to 1. Do you know why? If here x should be equal to 1 and I substitute and put 1 at the denominator, the result will be 0, and a number over 0 is always what? Undefined. So which means the domain of this function can never be what? 1. It can be other values. Am I communicating? But we are not looking at the domain here. Neither are we looking at the what? The range. But what we are looking is how to find the derivative of this particular word function. Are you ready now? Now let's see how we can solve it. Very simple. Now the next thing we are going to do here, look up. It is very, very simple. We are given that y is what? Log of what? 1 plus x, then over bracket 1 minus x to base what? A. Now consider the concept of logarithm. Do you know that if you are given something like this, log a all over log what? B under base what? 10. I will subtract, right? I will now have it as log what? A to base what? 10. Over means what? Minus. I will move to the next one and consider it as log b to base what? 10. This is one of the concepts under what? Logarithm. And that is exactly what I'm going to do here first before I differentiate. Can we continue? I will now say y is now equal to, how do we now do this? The base are the same and it is over, so which means it incur what? Minus. I will now say log of what? 1 plus x under what base? A. Are you with me? Over means what? Minus. It becomes the second one, which is log of what? 1 minus x under base what? A. Can we now begin to differentiate this one after the other? Check my part 3 and part 2 video. I taught logarithm differentiation. Can we do it? If you differentiate y with respect to x, it will give you dy all over what? The x, then equal to. Now this is a natural law. I told you that natural law, if you are differentiating it, always say 1 over the value. 1 over the value. What's the value? 1 plus x. That's the first thing. The next thing is to differentiate the value, and the value is 1 plus x. Can we differentiate 1 plus x? This is a constant, throw it away. Then differentiate x. What is the answer? 1. Then you now multiply the numerator by 1 because the differentiation of this will incur at the numerator. Now, since this is not exponential, it's under base A. Remember to put a constant logarithm, which is log exponential, to the given base, which is base what? A. I'm done with this now. Then I will continue minus, differentiate this. It's also a natural law. I will say 1 over the denominator, the value. What's the value? 1 minus what? X. Then I will now differentiate 1 minus x to get the numerator. Can we do that? Now equal to, this is a constant, throw it what? Away. Differentiate minus x. What is the answer? Minus 1. So this is now times minus 1. Then repeat log, or let me use this bracket, minus 1. Then repeat log exponential to base what? A. Am I communicating now? Now can we continue? What exactly are we going to do? What this and this are the same thing. Now let us factorize. I will now bring it out and call it log exponential to base what? A. Open the bracket. What remains here is 1 times 1 is 1. Then all over 1 plus what? X. Then this one is minus 1 times minus 1 will give us plus 1 all over what? 1 minus x. Close the what? Bracket. What do you think that will happen here? I will take the LCM. I will take the what? LCM. So which means I'll be having 1 over 1 plus x plus 1 over 1 minus x. Close the bracket and call it log what? Exponential to base what? A. Are you with me now? To base what? A. Let's take the LCM. They are the same thing. What is the LCM? The LCM is 1 plus x followed by what? 1 minus x, which is this. If this cancel this, it will remain 1 minus x, right? Then 1 minus x times 1 is 1 minus what? X. I will add. I will do what? Add. If this divide this, it will disappear. It will give you 1. Remains this. Now this 1 plus x times 1 will give us 1 plus what? X. So what I have now is log exponential to base what? A. Are you with me now? Then what is the next thing now? Do you agree with me that minus x will cancel plus what? X. It remains what? 1 plus 1. And what is 1 plus 1? 2. All over. Are you with me now? Open the bracket. 1 times 1 will give you 1. 1 times minus x will give you minus x. Lastly, plus x times 1 will give you plus what? X. And the plus x times minus x will give you minus x squared. Then log what? E. Base E what? Is log exponential to base what? A. Are you with me now? So what do you think that will happen? Minus x will cancel plus what? X. So what is remaining now? What? It is now 2 all over what? I have with me 1 minus x squared followed by log what? Exponential to base A. This is how to solve a problem like this. Have I made myself clear? Now that is exactly what we are looking for. Do you understand? Do you